Okay, so then- in this video, I will talk about the setups uh, for Lab 9, essentially Lab 9 for experiments for experiment 1 and exercise 1 and 2. They pretty much do take a little bit of time, so I decided to make a side video for that, and essentially the link to the other videos will be in the description and vice versa. So if so happens that you click on the link to the video, then for the video of the experiment, then I will leave the description, and I will leave in the description the setup, which is what I'm going to talk about now. Okay, so let's get started. So essentially for the setup, so first we had to set up our UART, right, which is how we're going to communicate to our PC and vice versa. So essentially for our UART, we know that our UART baud rate, so the baud rate for the UART was 150,200, as we could see here, right? So that was our baud rate here. And essentially to find, the first thing that we needed to do was essentially find our baud rate divisor, the integer part, and then our baud rate divisor, the fractional part. So let's cut to that and let's see how to do that. Okay, so pretty much to find the baud rate division integer and the baud rate division the fraction part, this is the process that we do. So I'm gonna quickly run through it. So pretty much um, the first step, right, or the first thing that we know is that our system clock is 48 megahertz. So we know that, right? So we simply use this equation that I'm going to circle in green. We use that equation, which is basically says frequency UART, right? So the frequency of the UART is equal to the system clock over the divisor. Again, like in previous labs, the divisor could be any number, right? But I chose 8 because it fits perfectly to this situation. So yeah, so therefore we know our divisor, we know our system clock, and we also know our baud rate, right? Our baud rate is right here. Okay, cool. So now we plug everything in to the FUART equation, right? So we know our system clock, right, is 48 megahertz. So we plug in 48 megahertz. Again, our divisor, I chose it to be 8, right? And then I get the result to be 6 megahertz. Okay, so now that we have 6 megahertz, we have another equation that states that the baud rate is equal to the FUART over the baud rate divisor. Okay, so we simply just rewrite that equation and we get the baud rate divisor, right, which is here, is equal to the FUART over the baud rate. Okay, so we just found the baud rate, right? The baud rate, we found it right here, right there, which was 6. The baud rate was 15,000, 115,200, and we found the FUR, which was the 6 megahertz. So the FUR is the 6 megahertz, and the baud rate is the 115,200. Right? We plug those numbers in, and the total result that we get is 52.0833. Okay, so the BRDI is simply just going to be the 52, and then for the BRDF, it's simply the fractional part, right? So the ending part. So we get that number, we multiply by 64, and add 0.5 to that. And pretty much the resulting number that we get, we simply just get the integer part, because the result from this is equal to 5.83, etc., etc. But we just get the integer part, which is just 5. So therefore, this results in our BRDI just being 52 and our BRDF equal to 5. So yeah, that's how we find those values. Okay, let's get back to the code. Okay, So yeah, so that's essentially how we get those two numbers. And then now using those numbers, we can now essentially use our start establishing our UART setup. So the first line of code here is to essentially enable the clock to the UART module, right, which is module 0. And then this second line here, oh, sorry about that. This second line here says that it basically allows time for the clock to stabilize. And then this next line, it disables UART by clearing the UARTin in the UART CTL register. So yeah, that's pretty much what that does. And the next line, what it pretty much does is we use we are establishing our baud rate divisor, integer, and the integer part and the fraction part, right? Which is what we found above. So that's what we have here, right? This is what we are going to set this equal to. So we're essentially registering that. Then in part 4, we write about the UART line control, right? I'm pretty much essentially for this is pretty much the 8-bit data, right? And it has no parity, right? So it's no parity, and then no parity, and then pretty much it's a one-stop bit, right? And then it's we have to enable the FIFO, right? So once we do that, the next step would be to configure the UART clock, right? The source clock from the system clock, right? The clock source from the system clock, I mean. And then lastly, we enable the UART by clearing the unartin in the register. We essentially, here we're enabling the UART 0, the TXE, and the RXE. So yeah, so that's essentially how we do the UART part. So now if we look at the GPIO, right? So real quick, I want to go over the GPIO part. So essentially for experiment 1 and 2, right, we're going to add more things to experiment 1 and 2. So for experiment 1, we add 2 LEDs, so which is why we have port F, and essentially for experiment 2, we add a motor, right, and we know that motors, they use PWM signals to control the motors. So yeah, and pretty much essentially what port A is the TXE and the RXE. So that's how we're going to use the UART with port A, pins 0 and 1. Okay, so let's talk about this before I talk about the PWM for experiment 2. So for exercise 2. So pretty much, right, what's happening is we first enable the clock for the GPIO modules, right? So again, we use port A for the UART, port F for the LEDs for exercise 1, and then port K for the fan that we're going to add for the PWM for exercise 2. And then we have to allow the time clock for those ports as well. Then the next step would be to essentially set the port control register, right, for each port, and we do that for port A and for port K. So port A, right, because we're essentially sending some type of communication between the two devices, and then port K, we're essentially sending the PWM signal. And then for part 5, right, we set an alternate function, select bits, right, because again, it's basically a continuation for part 4. Then for part 6, we essentially have, again, we have output pins, right, because essentially we have our LEDs, which are the output part. And yeah, and then pretty much we have to enable all the ports and the pins that we're using. So yeah, that's the GPIO. So now for exercise 2, we pretty much have a PWM signal that we're going to use in order to make a motor spin, right? So yeah. Okay, so then for that, pretty much what we have to do first is we have to enable the PWM module, right? And pretty much from that PWM module, what's it called? We then have to essentially, after that, we enable the setup the clock, right? We have to enable and set up clock divider. So pretty much this is setting up the clock here, right? And then for the next one, we are setting up our divisor, right? And our divisor here, I use it as 4. And from previous experiments, right, we know already how to calculate the load and yeah, all that stuff using the divisor. So essentially, for the next step would be to disable the PWM generator and set up the time counting mode, which is what I do there. And then again, from previous experiments, from experiment 7, we already know how to calculate the load, right? So pretty much it's the exact same process. We pretty much use our divisor, our frequency, our PWM frequency, and yeah, and essentially our 2D and all that stuff. Yeah, it's explained here. See? So yeah, that's pretty much it. And then the next thing to do would be, we know that it's a left align, right? It's left align for the motor. Again, for this one, we could choose because essentially it was up to us to how we wanted to code the PWM part. But I essentially did left align because I'm more comfortable with left align because I already know how to do that. But yeah. And yeah, and so for part 5, we just have to enable the PWM generator. And then for part 6, we just enable the PWM output. So yeah, that's pretty much all we had to do. So yeah. Now in the next video, I'll leave the links in the description. It's going to be basically about the actual projects and yeah, all that. Essentially, how we use all this setup here, and the reason why we use it, and yeah, all that stuff. So yeah.